Now that we have seen the behavior of lines in 3D space, let's see how the lines could be constructed on a 2D sheet of paper. We'll be referring to the rules which we have learned in the last section while we'll be doing the problems in projection of lines. And we'll be looking at specifically two different construction techniques or methods. One is called the line rotation method, and second, the plane rotation method. So we'll start with the construction techniques for the line rotation method initially. Let's start by trying to solve two problems in projection of lines. The first one being a line which is parallel to both VP and HP, the simplest case, and second one, a line which is inclined only to one of the planes, that is, it is inclined only to the HP and parallel to VP. And slowly we will move on to the case where the line is inclined to both the planes. And these are the questions which we'll be doing as problems. So please look at these questions. I'll read out the questions for you. First one is a line AB is of length 50 mm and is parallel to VP and HP, and the end A and B are 10 mm in front of VP and 20 mm in above HP. Draw the projections. And second question, it is a line PQ of length 75 mm inclined to HP and parallel to VP. The point P is 20 mm above HP and 15 mm in front of VP, and the end Q is 40 mm above HP. Draw the front and top views. Saying draw the front and top views and saying draw the projections actually both mean the same. So let's dive in and see how this could be constructed. So let's try to solve the problem 1 first. So first of all, we'll be drawing an XY line. So we draw an XY line like this, and we'll try to enter the points one by one. So if you look at it's a line AB of length 50 mm and is parallel to both VP and HP. So if you recall what we learned in the last section, both, since it is not inclined to any of the planes and are parallel, you can see both views should be parallel to the XY line. So for example, this point A I can mark first, so which is at a distance of 20 mm. So any distance from the HP will be seen in the front view, which we learned before. So I mark A dash, which is the front view, as given it is 20 mm, and similarly I project the same point here in the top view, and that is given as 10 mm, so approximately here. So I mark point A, and then since it is parallel to HP and VP, it will be a horizontal line, so this both A dash and B dash will lie in a horizontal line. Similarly, AB will also be a horizontal line, and both will be equally away from the XY line. Or in other words, when you say the point A dash is 20 mm above HP, B dash should also be about 20 mm above HP. Similarly, the point A is 10 mm in front of VP, and B should also be 10 mm in front of VP since it is parallel to VP. So that's the result for first question, and you can mark this distance as 50. You can probably write TL equal to 50, which represents the true length. So let's quickly jump into the next problem. So again, we'll start with the XY line. So XY line is drawn, and then we'll start with the points P and Q. So first of all, we'll mark the points P. So as given in the question, the point P is 20 mm above HP. So naturally it should be above XY. So that is P dash, and 15 mm in front of VP. So that is P. So the technique of drawing projections is you start initially by locating the endpoints based on whatever data is given. So in this case, both the positions of endpoints from the XY line or from the HP and VP are given. So we are trying to do that first. And the next data given is that the NQ is actually 45 mm above HP. So that is, you mark the point Q dash, and we can easily join P dash Q dash. So this is actually the true length here, because why is the true length? It has to be the true length because it is parallel to VP, and we learned that when a line is parallel to a plane, the view on that plane will be the true length. So in this case it is parallel to VP, so the view, the front view which is coming on the VP will have a true length. And similarly, one more rule you can recollect here is that if a line is inclined to only one plane, in this case it is inclined only to HP, and parallel to another plane, parallel to the other plane, that is VP, that particular view will have two properties. One is it will be horizontal, or it will be parallel to XY line, and at the same time it will be foreshortened. It will be a length shorter than the true length, and which again is due to the reason which we told in the last section. This length PQ is nothing but actually P dash Q dash cos theta, which is this angle. So we are not given the angle here, but we are directly given these distances. So this is where I'd like to point out one important thing about the data, that is some data. That is, one is the position of first point and the position of the second point. This could be given in multiple ways. One is the position of point P from the XY line, and position of Q from the XY line, and the true length. These three data together can be used to draw this line, which is given here. The same question can be asked in a different way, where instead of giving this data, they could also ask or give this data, which is angle. So maybe the question might be a line PQ of length 75 mm is inclined to HP at say some angle, say let's say 30 degrees, and it will say that the other end P is 15 mm in front of VP. This could be the question. So here again the true length and the angle is given, and this distance is not given. So question can be in multiple ways. So for this problem we have solved it. That is, we started with the point P dash and P, marked them, then marked Q dash, projected it down, and we have drawn PQ. But how do we draw PQ horizontal? Because we know that since it is parallel to VP, the other view has to be horizontal and parallel to XY. So we are sure that PQ will be parallel to XY line. So, and to find the point Q, we simply project the point Q dash down to get the point Q. So this is the way we solve the second problem.